NEC, or the National Electrical Code, is a widely adopted standard for the safe installation of electrical wiring and equipment in the United States. It is not a law itself, but it is often adopted by state and local jurisdictions, becoming legally enforceable. The NEC provides comprehensive guidelines and regulations to minimize electrical hazards and ensure the safety of people and property. It covers a vast range of electrical topics, including wiring methods, overcurrent protection, grounding, equipment installation, and special occupancies. The NEC is updated every 3 years to reflect advancements in technology and address emerging safety concerns. These updates are crucial for electrical professionals to stay current with the latest best practices and code requirements. The code is organized into chapters, articles, and sections, each addressing specific aspects of electrical installations. For example, Article 210 covers branch circuits, Article 250 covers grounding and bonding, and Article 300 covers wiring methods. Each article provides detailed requirements for the design, installation, and protection of electrical systems. Compliance with the NEC is essential for preventing electrical fires, shocks, and other hazards. Electrical inspectors use the NEC as the basis for evaluating electrical installations and ensuring that they meet safety standards. Proper understanding and application of the NEC are critical for electricians, engineers, contractors, and anyone involved in electrical work. The NEC provides tables, calculations, and examples to assist in the proper selection and sizing of electrical components. For instance, Table 310.16 provides ampacity ratings for conductors based on their insulation type and installation conditions. These tables are essential for ensuring that conductors are not overloaded and can safely carry the intended current. Grounding and bonding are critical aspects of the NEC. Proper grounding provides a low impedance path for fault current, allowing overcurrent protective devices to quickly clear faults and prevent electrical shock hazards. Bonding ensures that all metal parts of an electrical system are at the same potential, reducing the risk of electric shock. The NEC also addresses special occupancies, such as hazardous locations, healthcare facilities, and swimming pools. These locations require additional safety measures due to the increased risk of electrical hazards. For example, hazardous locations require the use of explosion-proof equipment to prevent ignition of flammable gases or vapors. Healthcare facilities require isolated power systems to protect patients from electrical shock hazards. Swimming pools require special grounding and bonding requirements to prevent electric shock hazards in and around the pool area. Overcurrent protection is another critical aspect of the NEC. Overcurrent protective devices, such as circuit breakers and fuses, are designed to interrupt the flow of current in the event of an overload or short circuit. Proper selection and coordination of overcurrent protective devices are essential for protecting electrical equipment and preventing fires. The NEC also addresses the installation of specific types of equipment, such as transformers, generators, and motors. Each type of equipment has specific installation requirements to ensure safe and reliable operation. For example, transformers require proper ventilation to prevent overheating, generators require proper grounding and bonding, and motors require overload protection. The NEC is a complex and comprehensive document, but it is essential for ensuring the safety of electrical installations. Electrical professionals must have a thorough understanding of the NEC to design, install, and maintain electrical systems in compliance with code requirements. Now let's shift gears and talk about C programming. C is a powerful and versatile programming language that has been widely used for decades. It is known for its efficiency, flexibility, and ability to directly access hardware resources. C is a compiled language, meaning that the source code is translated into machine code that can be directly executed by the computer. C is a procedural language, meaning that programs are structured as a series of procedures or functions. These functions perform specific tasks and can be called from other parts of the program. C provides a rich set of data types, including integers, floating point numbers, characters, and pointers. Pointers are a unique feature of C that allows programs to directly access memory addresses. This gives programmers a great deal of control over memory management, but also requires careful attention to avoid errors. C is a low-level language, meaning that it provides direct access to hardware resources. This makes it suitable for developing operating systems, device drivers, and embedded systems. C is also a high-level language, meaning that it provides features that make it easier to write complex programs. These features include functions, structures, and header files. C is a portable language, meaning that programs written in C can be easily compiled and run on different platforms. This is due to the fact that C is a standardized language, and there are compilers available for a wide variety of platforms. C is a widely used language, and there is a large community of C programmers. This means that there are many resources available to help programmers learn C and solve problems. C is the foundation for many other programming languages, including C++, Java, and Python. Learning C can provide a solid foundation for learning these other languages. C is a powerful tool for developing a wide variety of applications. Its efficiency, flexibility, and portability make it a popular choice for programmers around the world. The example code provided is a simple Hello NEC program written in C. This program demonstrates the basic structure of a C program. Let's break down the code. Firstly, #include stdio h. This line includes the standard input/output header file. This header file provides functions for performing input and output operations, such as printing text to the console. Secondly, int main void. This line defines the main function. The main function is the entry point of the program, meaning that it is the first function to be executed when the program is run. The int keyword indicates that the main function returns an integer value. The void keyword indicates that the main function does not take any arguments. Thirdly, print hello NEC. This line calls the print function to print the text hello NEC to the console. A character is a new line character, which causes the cursor to move to the next line after the text is printed. Lastly, return 0. This line returns the value 0 from the main function. The value 0 indicates that the program executed successfully. To compile and run this program, you will need a C compiler. A popular C compiler is GCC, the GNU compiler collection. To compile the program, save the code to a file named hello. C and then open a terminal or command prompt and navigate to the directory where you saved the file. Then type the following command gcc hello co hello. This command will compile the hello C file and create an executable file named hello. To run the program, type the following command /hello. This command will execute the hello executable file, which will print the text hello NEC to the console. This simple program demonstrates the basic structure of a C program and how to use the print function to print text to the console. C is a powerful language with many features, and this is just a starting point. As you learn more about C, you will be able to write more complex and sophisticated programs. Remember to consult documentation and practice coding regularly to solidify your understanding of both the NEC and C programming.